Hi, my name is Jacob Bodien, and on behalf of my teammates Dakota Bowman, Stephen Brinkly, and Michael Field, I will be presenting our manufacturing design project. We worked with a company named Betajet in order to create a new mold for their injection molding machine. They had one previous that they got rid of that had molds for it already, and those molds did not fit this new machine, so Joseph, the shop manager of Betajet, wanted us to create a new mold and also do the injection molding. He wanted us to create a new mold out of an aluminum epoxy. I'll be showing you that further along in this video, as well as do the injection molding as I said previously. So without further ado, we'll go on. In order to create the mold, we had to take many precise measurements in order to ensure that we had a proper fit of the mold that we were trying to create. As you can see here, we're using calipers in order to take the dimensions of the slot, as you can see here, that the mold was being put into. We needed to make sure that the fit was not too tight and also not too snug. Injection molding needs to be done properly, so it has to have a proper pressure distribution on the mold, so a pressure gradient can be made with the plastic and the mold itself. So as you can see here, we're taking these measurements as well as the other larger measurements of the machine. We put them all into CAD. Joseph, the shop manager, had a CAD file already for the previous molds. We had to make a few adjustments because this new machine had different measurements. What you cannot see here is a template of, or a negative of the mold. Since we were pouring an epoxy into a mold, we needed to ensure that we had a negative. So the mold that we are creating here comes out the way that we need to, as you see here. So we fixed the dimensions on the negative, and we had them send it off to China. Betajet does not have an in-house machining shop, so they needed to send it elsewhere in order to get it machined, so they sent it off to China, and they had it sent back. They created the template or the negative out of aluminum and machined it for us and sent it back to us. And we used that along with a couple other things that you'll be seeing here in a second in order to create the new mold. So for this injection mold, they wanted to have an ability to quickly swap out injection molding pieces. So the cavities that they're using for the plastic parts, they wanted a way to quickly switch those out. So they wanted us to make an outer shell with a cavity inside of it, so that cavity could house the cavities for the plastic that are being created, so the actual injection molding piece. So we had to create a 3D printed part in order to create that cavity inside our shell, which is what we're actually making. As you can see here, it was created in two different parts, so we had to fuse them together. We glued them together. They had a larger 3D printer, but the first time that we printed something on it, it misaligned, so we had a failure on the print there, and one of the gears slipped the second time after we made some adjustments, so we had an issue with that as well. So we ended up having to print the part on a smaller printer in two separate pieces and fuse them together. And as you can see, whenever that was created, there was an issue with some bowing on the piece. You can see it is slightly there on top, but what we needed was a properly flat piece for our cavity, so we had to do some finishing as well. We had a couple different ideas to make it flat. One was to take some modeling clay and roll it out on top of the 3D printed piece in order to create a flat surface, as you can see in the top right-hand picture. That did not work out so well, so the shop manager, Joseph, had us build a frame on top of the 3D printed part, and he had some different plastic epoxy mixture that he wanted to pour on top of the 3D printed part and finish that top down in order to get a flat piece. So that's what we did. As you can see here, we sanded down the material that we placed on top of the 3D printed part, and it came out flat as can be. So then we were able to move on with the next steps. So as you can see in the bottom picture there, we are placing wax on top of the and around the 3D printed part. We needed to make sure that it would not slip and stick in the aluminum epoxy mixture. So we're alleviating any issues with removing the mold itself after it's created. As you can see here, we're preparing the negative. We had to bolt down the entire box to make sure that there weren't any openings for the epoxy to slip out of, and we had to spray it all down with mold release to ensure that the mold would slip out properly after we broke it off. We prepared the epoxy. It's a 10-to-1 mixture. Part A is in the yellow bucket there, and part B is that hardener that you see. Mixed it up and poured it into the cavity, and as you can see here, it was finished. We put a top on it to flatten out the bottom, and with the heat, it expanded out, and we had to clean some of that up as well. The final product here, as you can see, it's slid in perfectly into the machine in the top picture there. The bottom right picture is the top of the mold itself. We had some issues with air bubbles, and that's why you see those that rough surface finish on top there, but the bottom, as you can see in the bottom left-hand corner picture, the bottom is nice and smooth. Now, the problems that we had with this project were the time that it took for us to get all of the stuff back from China for the machine shop. We also ran out of the aluminum epoxy, so we had some issues with that, and we were not able to create the second half, and we were not able to put the new inner pieces for the injection molding cavities, so we were not able to actually properly injection mold. But these are the injection molding pieces and what they would have looked like had we have been able to do that. So with all of these things that happened, we were still able to learn a whole lot about different manufacturing processes.